Ever wondered how your GPS just knows the fastest way to get you home? Or how a character in a video game can navigate a super complex map all on its own? Well, it all comes down to finding the best path, and that's a classic problem in computer science. Today, we're going to pull back the curtain on one of the coolest solutions out there. So let's really think about this. Picture a massive, invisible maze with millions or even trillions of possible routes. A computer could just try every single one, but, that would take forever. The real trick isn't just about finding any path, it's about finding the absolute best one without wasting time.
And this quote from AI research just nails it. For a computer, figuring out a route isn't a small thing. The number of choices can be absolutely astronomical. So we're going to need something way smarter than just trying everything. We need a clever shortcut.
And that smarter way is exactly what the A-star search algorithm is. Instead of just blindly stumbling around, A-star uses a really intelligent strategy to focus on the paths that look the most promising. It's a game changer.
Okay, here's the secret sauce right here. It's this simple-looking formula. It calculates a score, we call it the F-score, for any spot on the map. And it's just two parts added together. First, you've got G of n, which is the actual, known cost to get from the start to where you are right now. That's the past. Then you've got H of n, our heuristic, which is basically just a fancy word for our best guess of the cost from here to the finish line. That's the future. A-star is all about balancing what we already know with a smart guess about what's ahead.
So what makes this so special? Well, think about a blind search. That's like being in a maze in the dark. You just feel your way around, checking every single dead end. A, on the other hand, uses its heuristic, its best guess, like a compass. It doesn't know the exact path, but it knows the general direction of the goal, so it explores paths that are actually heading somewhere useful. It's just so much smarter and faster.
All right, enough theory. It's time to see how this thing actually works in the real world. We're going to walk through a simple puzzle together, step by step, and watch A-star do its magic.
So here's our map. Our mission is to find the absolute cheapest path from our starting point, S, all the way to the goal, G. The numbers on the lines connecting the dots, that's the actual cost to travel between them. And the H value inside each circle, that's our heuristic, our best guess of how far it is from that point to the goal. Okay, let's get started. Step 1, we evaluate our starting point, node S. The cost to get here, G of S, is obviously 0 since we haven't gone anywhere yet. And the map tells us our heuristic guess from here, H of S, is 7. So we add them together. 0 plus 7 gives us a total F-score of 7 for our start.
Now, to keep track of everything, we use something called an open list. Just think of it as our to-do list for places to explore. But it's a special kind of to-do list. It's a priority list, which means it always keeps the option with the very lowest F-score right at the top. So for now, the only thing on our list is our starting point S with its score of 7.
All right, we take the top item from our list, that's S, and we check out its neighbors. We can get to A, and we can get to B. So let's calculate their F-scores. For A, the path costs 1, and its heuristic is 6, so that's a total score of 7. For B, the path costs 4, and its heuristic is 2, for a total of 6. We're going to add both of those to our to-do list. And right away, you can see the magic of the open list. S is off the list because we've explored it. We've added A and B, and look, the list automatically sorts itself. B, with its F-score of 6, jumps to the top because it looks more promising than A, which has a score of 7. This is the heart of A-star. Always check out the path that looks best right now.
So we follow the rule. Expand the best option, which is B. From B, we see we can get to node C. To get its score, first we need the total cost to get here. That's 4 to get to B, plus 2 to get from B to C, so our G-score is 6. Now we add C's heuristic, which is 1, and this new path gets an F-score of 7. Let's look at our list again. We've explored B, so it's gone. We've added C with its F-score of 7. Now wait a minute. We have a tie. A and C both have a score of 7. When this happens, the algorithm just has a simple rule, maybe picking the one that was added first. So let's explore A next.
So now it's A's turn. From A, we can see two new possibilities. First, there's another path to C. The cost to get there is 1 plus 5, which is 6. Add C's heuristic of 1, and the total is 7. Well, that's not any better than the path we already found. But wait, from A we can also see a direct path to the goal G. The cost is 1 plus 12, which is 13. The goal's heuristic is always 0, so the total F score is 13. Let's get that on the list.
Okay, checking our open list again. After all that, our most promising option is still C, with its score of 7. That direct path to G we found is on the list, sure, but with a score of 13, it's not our best bet right now. The algorithm is smart enough to know that. So, next up is C.
And this is the key moment. We expand C. Now remember, the best path to C was S to B to C, for a total cost of 6. From C, we can get to our goal G for just 3 more. That gives us a total path cost of 9. Add the goal's heuristic of 0, and the final F score for this amazing new path is 9.
Now look at our open list. This is just fantastic. We now have 2 different ways to get to the goal on our to-do list. The old path through A had a score of 13, but this brand new path we just found through C has a score of 9. That's way better, and our priority list instantly promotes this cheaper path right to the very top. It is now the best option we have, period.
So we've done all the work. We've explored the possibilities, and now the algorithm has everything it needs to tell us the absolute best way to go.
And here it is. The number 1 item at the very top of our priority list is now the goal itself, with that winning score of 9. This means we're done. The search is over. Because A* is guaranteed to find the best path, and any other option left on our list has a higher score, there is no way we can find a cheaper route. We've found the one.
And by tracing our steps backward, we can see exactly what that winning route was. It's beautiful, from S to B to C, and finally to our goal, G.
And the total cost for that optimal path? As we calculated, it's 9. That is the guaranteed cheapest route through our map. No question about it.
So let's just zoom out for a second. The algorithm found the path, sure, but what was the real hero of the story? It was the heuristic. That's what did all the heavy lifting. Our series of best guesses is what allowed the search to smartly ignore the bad paths and focus only on the ones that really mattered.
And that right there is why A* is such a legend in computer science. It has this perfect balance of known costs and estimated future costs. But here's the most important part. As long as our heuristic is admissible, which just means our guesses are always optimistic and never overestimate the real distance, A* is mathematically guaranteed to find the single best path. It's not just a good algorithm, it's an optimal one. And it's powering so much of our world, from GPS navigation to video game AI.
So, the next time you ask for directions or you see an AI character perfectly navigate a tricky level, you'll know the elegant logic that's probably humming away behind the scenes. It really makes you think, doesn't it? Where else are these kinds of smart, guided searches making decisions for us every single day?